Hello again, and welcome to part 2 of our IBM proven practices on TM1 feeders. So in part 1 then we've examined this document. It's available on the old Developerworks site, and we went through the introduction definitions, where are feeders defined, and determining if a cell has been fed. Had a few examples in there. We've got a cube that we've built some processes to generate the cube, so you can test the examples yourself. So in part 2 we're now going to have a look through defining the feeders, conditional feeders, etc. We're going to start working through the rest of this document. So again, the code that's available for this to replicate all of these examples is available on the link inside the comments, and you should be able to replicate these and see them happening and pull. I would encourage you to pull and push them just to sort of see how they work and what they do. So for this session we're just going to talk through the rest of these examples and then sort of highlight a few important aspects. So in terms of defining feeders, we have a number of different types of calculations. So here we've got listed 1 through 6, so we've got multiplication, division, addition, subtraction, conditional, and cube to cube. So this should generally cover most of the rules and feeders that you need to apply. So we're going to go straight into it. So if we remember from the first section that we're talking about when you might require feeders, so we're talking about activating the sparse consolidation algorithm, and ultimately we're only wanting to feed results for calculations where we're expecting a result to come back. So we've already had the discussion about overfeeding and underfeeding, and so in terms of a multiplication aspect, it's quite a simple, straightforward example. It's the standard IBM examples, which is your revenue calculation equals the number of units sold times the price. Now from this calculation then we would reasonably expect that price would always be populated, and so then if we fed from price, then we're going to create a lot of revenue calculations where we've got no units that have been sold. Now ultimately, if no units have been sold, then that's not a calculation that we're concerned about, because we don't have any results to return, there will be no revenue. So in this instance then it's quite a standard feeder which will be focusing on the units. Now there are two different ways in which we can define the feeders, the actual statement itself. So if it's an intercube feeder, then we can use the square bracket notation to pick out the individual elements it might be related to, and then there are a few different conditions where we might need to go into the full database reference statements. So here we go, you're not normally necessary to use a DB format unless you were defining cube-to-cube rules, defining a conditional feeder, or manipulating the feeders so that the feeder elements match target elements. Now I would add in that there are circumstances where you may benefit from including these statements even if it's into cube, just for legibility or familiarity or consistency across your rule statements, because if you start shortening your feeder statements, and you might, as you're scrolling down and trying to bug fix or trying to ascertain exactly what's going on, you may skim past it, because if all of your left hand side of your calculations are all square bracket notations, you may sort of unconsciously avoid square bracket notations, think that that's not what I'm looking for. I'm looking for DB statements. So it's down to your own sort of considerations on the size of your individual feeder statements or rules files even, that to make that assessment. But it's a bit of a ad hoc, as and when to choose which is the most appropriate for you. Now we have exactly the same situation in division. So again, we're only going to do the division feeding based upon the item which we're anticipating that is going to be the item that's not 0 that we need. So then if we were going to do this as a divisor of price or quantity or whichever metric is necessary, then you would pick the one which would then result in the calculation of the values that you need. Addition and subtraction are slightly different, because as you might anticipate, if you're adding a 0 to another number, you're still going to want that other number, and so that 0 can be on both sides of the equation, which then means that you will have to feed from both sides. But again, as we saw in the first videos, that if you can put that where possible inside a consolidation, then you will alleviate that need. You'll get you can take advantage of the hierarchies there to improve performance significantly. but you may need to put additional subtraction in there as part of a wider calculation, or just because it improves the legibility of your models. Conditional rules will be very frequent, so this will just mean that you can hone in on the selection of values that you need to calculate for. So most commonly this is used in a kind of rolling forecast type basis, and this is the example that they're using here, or at least that's one of the common usages for it. So in this example here, we're seeing that our calculations are only processed where the actual flag is set to A, so where it is marked as an actuals value, so where it's not marked as an actuals value will then be where we'll perform our calculations. So if there is no actual flag, so if there's no actual flag, then take E times F, otherwise stet it out, so otherwise leave it alone. So as we can see here, then that feeder will only apply to those cross-sections of values that have been calculated. Now, as we start to get into slightly more complex models, starting to go into multiple cubes, then we're going to be looking at cube-to-cube rules. So we have a basic example here. So we've got a simple sort of maybe a rates cube, allocation-based table, some sort of metrics that we've got that we want to apply into another cube. So we've got a single value against value and source in our feeder source cube, and then we've got a feeder to target cube where we're then saying that we would like to send this single value into every single instance inside of our subsequent cube. So here we've got a target value where we're saying that every single value, the value for target is the value that exists within the feeder source at the cross section of value and source. So we can see we've got a single value here, and now we're loading that into every single n level element, every single lowest level element inside of our cube. Then we've got some examples to sort of reiterate this. So these are, as I say, they're all in the notes that are available. So we've got a whole set of statements that will generate the cubes for you, the dimensions. You will need to add in some of the rules where they're necessary, but that will be part of the part that we would encourage you to try and test and play around with, just to see how they work and just to validate your understanding. One of the key instances that we want to take away from part one is that you may need to unload the cube or delete your persistent feeders, which we'll talk about in a moment, to make sure that you're looking at the right values. So it's useful to understand when these feeders are firing and then whether they'll persist. Now we have a selection of notes with regards to feeders. So these are quite useful. So feeder is defined as a reverse of the rule. So generally speaking, any rule that you've got, then if you just flip those two around, then you should have the basis of what your feeder is looking at, and you'll need to conditionalize that according to these lines to generate what would be the right feeder. Now that's an oversimplification. Sometimes that will, in the main, that will work, but there will always be instances where that may not be appropriate. So if the same dimension is in both the target and the source cube, then you can just use the bang dimension name. So you're using the same dimension name in there, so then you can just utilize them at the same time. That's fine. If you are using mirror images of two dimensions which contain similar values, then when you're writing the rule, you must use the dimension name in source. Otherwise it won't work, because it won't recognize it. But the error message that pops up will tell you that it can't find that dimension. If it can't find that dimension, that's your cue to go look back at what the dimensionality of your cube is, to then work out whether you are referencing the correct dimension that you need. Now if you have a dimension in a target that does not exist in the source, then you will need to hard code that element. There is no way for your rule to find out what that element is, because you haven't given it that information. So in these cases, then we need to hard code an element. So if we've got a time dimension that we need to include here, then, and it's not in our other cube, then we need to hard code that value to tell TM1, tell the system where it needs to look to find those values. And then it's the same in the reverse. Then if you want to target a particular element, then you can just hard code those values. So anytime you're doing any hard coding, you need to make sure that that is something that will not change. So if there is any chance that will change, then you've got an option there to try and review how to make sure that it remains dynamic, whether that's referring to a central control cube or however you need to process it. Maybe at the start, in terms of generating your rules and feeders to start off with, you're looking at one individual cross section at n level just to make sure you've got it working and the feeders working, and then you want to scale that up to make sure it's dynamic and is fit for purpose. And so essentially you need to send from the source cube must match the element in the target cubes. Now, we have some circumstances where you may be able to avoid feeding. There may be some multiple calculations that you've got running across different cubes. So here we've got an example where an element target times C at the n level is equal to the feeder source value, a cross section of value and source, times the element C. Now, in the traditional manner, what we're looking at here, if we're doing our units, revenue equals unit times price, then we are trying to find the one which is if not zero, that is relevant for us. Now here what we've got is a circumstance where one value is in the same cube and one value is in another cube. So actually what we can do here is we don't need to worry about feeding this source, because if we feed it from the other element within the same cube, then that will automatically pull that value in. So we can now say here from this feeder, as long as that is the appropriate calculation for you, then you can feed target star C from the value C. Conditional feeders start getting very complex very quickly, but there's a very good simple example here. So we've got here a calculation where element A then is fed by, or element A rather, implies that there is a value in, and now we've got our DB statement with a if clause inside. So it's saying for element A that if element B is 0, then don't process it. Otherwise, then it will be completing this DB statement to then say overfeed source for time and product A star B. And again, for element B, then it will do exactly the same thing, but against element A. So what we're doing here is we're saying that for this first feeder statement, if the value for B is 0, then don't feed it, don't process any feeders. Now this can reduce the overhead or reduce the number of feeders that are required in the cube, which then can reduce the number of calculations that are being performed and the memory footprint. So you can use conditional feeders to reduce the performance overhead on your systems, but you do need to be a little bit careful about when they're going to get fired and how they get updated. But this is a basic example of what you can see how you can get that going. So onto that note, then we're going to move on to how often do feeders fire. So this one I would encourage you to definitely look at the code and run some checks on, and just to get that visual recognition of when that's happening, because if you set up a feeder and it is not firing on data change, which is a traditional aspect of when you want these feeders to update, then you're going to be missing out on values and your model won't be complete as you need it. So essentially what we're saying here, that there's a difference between when numeric cells fire and then from string cells firing. And it's quite a good example here where we're switching between the dates and we're setting something from a string element and from a numeric element to determine when they're firing. So I would definitely encourage you to investigate that in a lot more detail. We may well run another video on that just because it is such a good topic. Now, persistent feeders, depending upon what version you're running on, may or may not be switched on, and also depending upon how your model is set up, may or may not be switched on. Now, persistent feeders, there's a lot of good information, particularly on the TM1 forum about this, about whether to have it on or not. I'm generally of the mindset you should have it on. There's very little drawback to having it switched on. There's always going to be pros and cons for which way you're going to run it, but in the main it means that your startup times are a lot quicker because your feeders are all calculated and saved to an individual file, and so then each time you switch your system on, it doesn't need to reprocess all of your feeders. Now there may be circumstances where you need to reprocess all of your feeders, but you still want to have persistent feeders switched on, but there are ways around this as well. So you've got another item which is delete all persistent feeders. Again, persistent feeders is a big topic, so it's not something I'm going to be able to cover in full detail here, but again, this is a starter for 10, somewhere to give you an indicator of it, to do some more research and have a look into it. So I definitely encourage you to read up more on the IBM documentation with regards to conditional feeders and persistent feeders. And then again, we've got this complex feeder example, which is going from line item detail to summary. So you may well end up, particularly from a budgeting perspective, you may well have all of your elements set out in your full nominal structure, and then maybe a summary nominal structure, and you may want to feed in between, particularly your actual values between them. So this again is another good example to see how you would enact that and what the kind of problems you will have with it. So again, all of these are in the code that will be attached to this video, so you can just copy that process out. It's in the prologue and a data tab that will then epilogue that will then populate the data in them as well. You will need to add the rule files, the rule details in there, but this document contains all of the information in there, and the TI process I've provided will save you a lot of time to try and look at these examples. And again, there's a PDF of this content. So that's the end of the feeders section, and hope you've enjoyed it.